Alright, section 3.3, we're looking at two basic rules of probability. The first one is the addition rule. So, anytime you have an or probability, like you do here, probability of A or B, you're going to use the addition rule. So this is talking about the probability of A occurring or B occurring or both A and B occurring in a single trial. Okay, you roll the die once, you pick a card, just one card, or you flip a coin once. This is just one single trial. Now, last time we learned about mutually exclusive events. Another way of saying mutually exclusive is disjoint. These two things mean the exact same thing. So remember, these two things cannot occur at the same time if they are disjoint from each other. So we've got two cases, whether you have disjoint events or not disjoint events. So that's going to change our formula just a little bit. If it is disjoint, then the probability of A or B, all you have to do is add the probability of A to the probability of B. If it is not disjoint, then you have to tack on this little bit right here, minus probability of A and B. Because remember, if it is disjoint, the probability of A and B equals 0 if it is disjoint or mutually exclusive. But if it is not disjoint or not mutually exclusive, then the probability of A and B will not be 0. So since it's not 0, I mean, you could subtract 0 from here, but it's not going to do anything. It's not going to change anything. But since this one is not 0, then you have to subtract off the extras. And this will make more sense here in a minute. Now, this is just to say right here, remember, this is talking about A and B happening at the same time in a single trial. We'll have another case where A and B is talking about two separate trials. Okay, a six-sided die is rolled. What's the probability of rolling a 2 or a 5? Okay, so if I roll this once, is it possible for me to get a 2 and a 5 at the exact same time? Well, no. So these are disjoint. So the probability of rolling a 2 would be 1 out of 6. There's only 1, 2 out of 6 numbers. Same thing for a 5. Since that is disjoint, this is probability of 2 plus the probability of 5. So 1 6 plus 1 6, 2 over 6, or 1/3. A spinner has 4 equal sectors colored yellow, blue, green, and red. What's the probability of landing on red or blue after spinning the spinner? Same thing. If I spin this one time, can it both land on a blue and a red at the exact same time? No. So this is still disjoint. So we're looking at the probability of red plus the probability of blue. Okay, so you have one red out of 4 colors, one side that is blue out of 4 colors. So this is 2 over 4, or a half, which should make sense because you've only got 4 colors and you're looking at will it land on a red or blue, which is half of your colors right there. Okay, a glass jar contains 1 red, 3 green, 2 blue, and 4 yellow marbles. If a single marble is chosen at random from the jar, what's the probability that it is yellow or green? Okay, if I take 1 marble out of this jar, can it both be yellow and green at the same time? Well, no. So again, this is disjoint. So we're looking at the probability of yellow plus the probability of green. So we have 4 yellow marbles, so 4 out of, well, 1 plus 3 plus 2 plus 4, that gives us 10. And then 3 green, so 3 over 10. So 7 over 10 would be our final answer. Single card is chosen at random from a deck of cards. What's the probability of choosing a king or a club? Okay, if I pull out a card, can one card be both a king and a club? Well, of course, you got the king of clubs. Okay, so this one is not disjoint because these two things can happen at the exact same time. So I need the probability of king plus the probability of club minus the probability of a king and a club. Okay, so we have 4 kings out of 52 cards, and we have 13 clubs out of 52 cards. Now I've counted the king of club once here and the king of club once here. How many king clubs are there? There's just 1 out of 52. So we got 4 plus 13 minus 1 all over 52. We'll give us 16 over 52, which that will round down to, or simplify to, 4 over 13. Now what happened was, if this is my probability for king, and this is my probability for club, well, this right here is the probability for king and club. So for this right here, we looked at all of this. We looked at all of that right there. And then what we did for probability of clubs is we looked at all of this right here, including this little section here. Now we have a double count for the middle part right here. We counted it once for the king and then once for the club. So what we're doing here, right here, is we're taking out the double count of this little section right here. Because you counted it once for the king, once for the club. Don't want a double count, so we have to subtract it once. And that's why we're doing this. Okay, in a math class of 30 students, 17 are guys, 13 are girls. On a unit test, 4 boys and 5 girls made an A grade. If the student is chosen at random from the class, what's the probability of choosing a girl or an A student? So can the girl also be an A student at the same time? Well, yeah. So this is not disjoint. Remember, that's going to affect the formula that we use. So probability of girl plus probability of an A student minus the probability of a girl and A student. Okay, so we have 13 girls out of 30 students. Okay, and we have how many people made an A? Well, 4 boys and 5 girls. So that's going to be 9 out of 30 minus how many of them were girls and A students? Well, just 5 out of 30. Okay, so now we've got 13 plus 9 minus 5 all over 30. And that's going to give us 17 over 30. So same thing, probability of girls, probability of an A student. This right here in the middle that got counted twice is girl and A student, or a girl who is an A student. Because we counted this twice, we have to subtract it one time, so we don't have a double count, and that will leave us with our final answer of 17 over 30. Okay, on New Year's Eve, the probability of a person having a car accident is 0.09. Probability of a person driving while intoxicated is 0.32. And the person having a car accident while intoxicated is 0.15. What's the probability of a person driving while intoxicated or having an accident? So can you be both at the same time? Well, yeah, said it right there. So this is not disjoint. So we need probability of intoxicated plus the probability of an accident minus the probability of being intoxicated and having an accident. Okay, probability of being intoxicated is 0.32 plus the probability of having an accident, 0.09, minus the probability of both of them happening together, 0.15. So our final answer is 0.26. Okay, what is the probability of randomly selecting a person who is guilty or did the crime? Okay, so can a person be guilty and did the crime at the same time? Well, hopefully that's the case. Okay, so guilty or did it. So we need probability of guilty plus the probability of did it minus the probability of guilty and did the crime. Okay, well, how many guilty people do we have? Okay, here's guilty. So we have 83 people that are guilty out of 11 plus 72 plus 85 plus 9. That gives 177. Okay, plus, okay, how many people did the crime? Well, 72 plus 9, and that's going to give us 81. So 81 over 177 minus how many people were guilty and did the crime? How many people are both of those at once? So right here, 72 out of 177. So you've got 83 plus 81 minus 72 all over 177. So that should give us 92 over 177. Now the reason we have a double count, or why are subtracting out that 72, we counted 72 once here for the guilty, and then twice for the people who did the crime. So we had to subtract it out once so we don't have a double count. Okay. Then we're talking about complementary events. So if you have the probability of A plus the probability of the complement of A, that's equal to 1. Then what you can do is kind of rearrange the formula to solve for the probability of A or the probability of the complement of A. So if we have the probability of A plus the probability of the complement of A equal to 1, and I wanted to solve for the probability of A, I just need to subtract the probability of the complement A from both sides. To get the probability of A is equal to 1 minus the probability of the complement of A, which is what you get right here. And you would essentially do the same thing for solving for the complement of A, except for you would subtract this one right here instead. But this is just to show you that you can kind of finagle this formula right here and solve for either the probability of A or the probability of the complement of A.